targets, and we'll get into our topic. So the first target, we are going to learn about the basic terminologies, and then we are going to see the genesis of earth magnetism, and then we are going to learn what actually geomagnetism is, and then we'll see what is paleomagnetism. So these are our today's target, and let's get started. So first we'll see the basic terminologies in Earth's magnetism or geomagnetism. The basic terminology involved in Earth magnetism is, first is the geographic pole or the true pole. Geographic pole or true pole is simply nothing but the axis of the earth, which we can see in this diagram. This is the geographic north pole and this is the geographic south pole. This is the axis where earth rotates in this axis, and it is inclined to 23 and a half degrees to the surface. And so this is what a geographic pole or true pole is. And then next we'll see what is magnetic pole. Magnetic pole is nothing but quite opposite to the geographic pole, where the north pole of the magnet is in the southern hemisphere, or the south pole of the geographic south pole, and the south pole of a magnetic south magnetic pole is in the northern geographic pole or northern hemisphere. So this is what a magnetic pole is. And then we'll see the what geomagnetic pole is. And geomagnetic pole is nothing but it is a quite opposite to the magnetic pole and quite similar to the geographic pole. If you consider this as a geographic pole or the true pole, this is geographic pole or true pole, which is inclined to 11 degrees or 10 and a half, approximately 10 and a half degrees or approximately 11 degrees to the geographic poles. If you consider this is a geomagnetic north pole or a geomagnetic pole, or this is the axis which is geomagnetic pole, this is the geomagnetic pole line, and this is the axis of the earth or a geographic pole, which is inclined at 10 and a half degrees or 11 degrees. So here we need to understand a thing, that if the inclination is eastern side, if you consider this north, south, and this is east, sorry, this is east and this is west. So if you consider this is east and west, north and south, then if the inclination is towards western direction, then it is a negative magnetism. So, no, sorry, negative declination. This we'll see in later. And if it is in towards the eastern side, then it is positive. So this we need to know from this diagram. And then let's see what where does the earth magnetism started, and what are the theories involved in magnetism. So the first and the oldest theory was given by scientists was about the earth is kind of a earth has a kind of bar magnet, which is consisting of north pole and south pole, which is embedded into the surface of the interior of the earth. So this postulation made by the scientist is not correct, because the interior of the earth, or in the mantle area, there is very high temperatures. Due to the temperature, there is a melting, or there is melting takes place, and the poles will get diminished. So there is a chance of north and south pole missing takes place in the interior of the earth, due to the molten stage is present in it. So this postulation made by scientist is not correct. Then we'll see the second postulation made by the scientist is that the rock property. Actually this phenomena will say that if you consider this earth surface, and this is the rock which is present on the earth, this is the rock present on the earth. So this rock contains the magnetic property, which was said by the scientist. But actually if you consider, the earth magnetism is involved in its interior, not in the surface of the earth, or the surface the rocks which are on the surface of the earth. So this postulation also cannot explain the magnetic reversal which takes place in earth's interior. And it is also the wrong interpretation made by the scientist. So then let's see the similar or quite preferable theory, or quite preferable study made by scientist is the core of the earth. So if you consider the core of the earth, this is the core. If you consider this part, I have taken this part and I have drew here. So this is the solid inner core, which is iron rich, and this is the fluid outer core with loose electrons spinning. Due to the earth's rotation, there is a spinning of electrons takes place in interior of the earth. Because of its molten stage or because of its fluidity, these electrons revolve around the solid inner core, and it is ferrous rich, that is iron rich. So due to its iron rich and electrons revolving around it, there is a kind of electric field is generated, and due to the electric field, there is a magnetic field. Due to electric field, magnetic field is generated. So here the electric field which helps in strengthening the magnetic field. So this is partially correct, and we'll see what next things. So we'll get into the what geomagnetism is. So here actually geomagnetism was first studied or first postulated by William Gilbert. So he is an American scholar, and he said that the interior of the earth or the magnetism is due to rich iron present in it. So the magnetism is due to the rich iron in the interior of earth. So due to this, there is a magnetic property or magnetism takes place. He postulated or he said that based on three components. He explained in using these three components. The first is the magnetic inclination. So let's say this diagram. Here you can understand that by seeing this diagram you can understand that there is a declination in angle. So if you consider this is the northern geographic pole and this is the magnetic pole, there is a declination or there is a angle made with respect to the geographic pole. This is the angle made with respect to the geographic pole. This is the positive declination. So which we have seen earlier, this is positive declination towards east. Towards east this is positive declination, and towards west this is negative declination. So positive declination and negative declination. So this we have seen earlier, and this was given by William Gilbert. And then next he said that due to the magnetic inclination, so the second component given by William Gilbert is a magnetic inclination. Magnetic inclination is nothing but if you consider if you do an experiment, that if you take a bar magnet which is having north pole and south pole, and also take a needle which is having north pole and sorry south, this is south and this is north, this is needle. And if you hang this on air, if you try to tie with a string and hang this, then and you bring this needle near to this magnet, so there is a attraction takes place. So this slightly deviates like this. If you bring towards the southern side, the northern pole of the needle to the towards the southern side, then there is a inclination deviation takes place. If you bring this towards southern side of the needle towards the northern magnet, then there is a inclination towards this. This is because if you exactly put at the center, there is a balance takes place. There is a balancing takes place. So this is we'll see in later. And if you consider this due to this as a earth and this as a compass, so there is an inclination made with respect to the earth's axis or earth layer. So if you consider this horizontal as earth's surface, and the compass made an angle or made an inclination, and the angle between the horizontal and the inclination is said to be the magnetic inclination. Or simply it is also said dip angle. So it is also said as dip angle. Now let's see the third component of the William Gilbert of geomagnetism. So the third component is magnetic equator. If you consider this as an equator, so here you can see that at the equator there is no inclination takes place, and it is parallel, the needle is parallel to the surface of the earth. So if you go towards if you consider this as northern pole, and here we are having south magnetic property, that is a south pole. In the northern pole we are having south magnetic pole. So if you bring this and if you consider this north and this blue color is the south, then there is a inclination when you move towards the northern pole, there is a inclination of northern pole of the compass, which is trying to attract the southern magnetic pole, when you move towards the northern geographic pole or the north pole. So this is what simply we can say the magnetic equator. This is what the magnetic equator, where the balancing of the needle takes place. So this is simply magnetic equator. Now let's say paleomagnetism. So paleomagnetism is a simple term where study and record of direction and intensity of magnetic field locked in the rock formed in different geographical time period. So if you consider, it is a study where the record and direction of the magnetic field, rocks are containing some certain kind of magnetic field. So the study of that kind of rock is simply said paleomagnetism. So here we are maintaining some kind of evidence with us for future evolutions. So this is simply said paleomagnetism. Now let's see what are the major contributions made to the paleomagnetism. The first major contribution was made by Runcorn. So initially he said that there is a continental drift takes place in the paleomagnetism. So he revived the continental drift theory, and he said that past 500 million years, the north pole of the earth is wandering around from Hawaiian Island. It started from Hawaiian Island since 500 million years ago. It started near Hawaiian via Siberia to the present Bathurst Island. So if you consider this, this is the Hawaiian Island. If you consider globe as a round, it started here and it came to here. Slowly it reached here, and Siberia, from Siberia to Bathurst Island. So present it is at the Bathurst Island. This is the Bathurst Island. So from Hawaiian to Bathurst Island. If you consider here the Hawaiian Islands. So if you consider globe as a this Earth map as a round on a globe, then you will see that this Hawaiian Island is present on the opposite side. So here, this is the opposite side. This Hawaiian Islands is present here. So if this travel took place from Siberia, that is Russian area, from Russia to the present Bathurst Island. So this postulation or this observation made by Runcorn was false. We'll see why it was false in the later stage. So next we'll see the Fredwine and Matthews um, in the paleomagnetism. So they said that paleomagnetism is due to the zebra strips. We'll understand this Fred Wine's and Matthews postulation by seeing this image. If you consider this image, there is evolution of time, or I can say that passing of time. There is a changes in surface of oceanic surface takes place. That is due, if you consider this is the ridge or mid oceanic ridge, where spreading takes place on both the sides. So this is a spreading because of lava eruptions. There is a seafloor spreading. So this spreading takes place. So while the spreading, there is stages. This forms a kind of stages where it brings new lava at one stage of time, and the new lava is moved away, that becomes old and it moves away. Then again the new lava comes and it stays near the ridge, and after passing of time, then again eruption takes place and it moves. So this process continues. Sorry. So this process continues. If you consider, the initially there is a this is the reverse polarity zone and this is the positive polarity zone. Initial 2 million years ago this has happened. So after passage of time, that is now 1.5 million years ago, so first we are having the negative polarity, that is reverse polarity, then we'll have normal polarity, then we'll have reverse polarity, and then we'll have normal polarity. This took place, and present we if we see that there is changes in this strips. So there is normal polarity, and there is reverse polarity and normal polarity. So this is what we have to learn from this, and we have to we'll see this in this diagram. So if you consider, if you are moving from ridge, if you consider this as a ridge, if you are moving from ridge to the other end of the ridge, uh, so you will find that the end of the ridge is the oldest, and this near to the ridge, the layer formed near to the ridge is the youngly formed layer. This is the young layer, and this is the old layer. This is because of the uh, kind of magnetism or lava eruptions takes place, and there is a seafloor spreading. So due to this spreading, both of the scientists, Fredwine and Matthews, they revived that seafloor spreading theory. So they revived this. If you consider this, both the sides will have the similar kind of strips or similar kind of the plane or surface. If you consider from ridge on the both the sides, here beside the ridge, this is if you consider positive, and this is positive, the next two is negative and the negative. So this both formed at same age or same time period. This both formed at same age or same time period. This we have to understand from this. And now let's see what are in which ways we can vary the earth's magnetic field, or what magnetic field of earth can vary in three ways. So the first is that magnetic intensity. So actually the magnetic intensity will not be the same. It will fluctuate, and which is not the constant one. And the next thing is the position of pole may vary, but the poles do not migrate to large geographical distance. So positions may vary, but they do not travel to the larger geographical distance. So the postulation or the theory made by Runcorn is incorrect. So this I said that we'll discuss later. So this is due to this, the Runcorn's postulation is incorrect. And the third one is that reversal of earth magnetism takes place. So we'll see some kind of facts. So the fact is, every 2 to 3 lakh years reversal takes place. That is, I will explain you the reversal, how reversal takes place. Present, if you consider this is a earth globe, and present we are having magnetic field south here, and north here, magnetic field of earth. And in future 2 to 3 lakhs years after or before, what happened or what is going to happen is, the earth magnetism is going to take complete reversal. That is, it's going to take the north and the south pole. So this will going to happen after 2 to 3 lakh years. So this will is a not a sudden process, this takes time. So this is a gradual process, and this is what happens. And here you need to be cautious that earth magnetic property takes the reversal, but earth itself does not reverse. And till now we have seen 170 reversals. If we consider from Mesozoic time till now, we have seen 170 reversals. So the last reversal phase was the Matuyama phase reversal. This is the last phase. So that's all for today. I will attach the PDF link with this video in the description. And